Hello everyone. Today I am going to start a new lecture series on how to make scientific plots with Python. So normally many researchers they use softwares like Excel and Origin to make publication quality plots. So today I will demonstrate how to make a simple line plot using Python. Please note that I am using a Linux OS. So I have saved my data into a file called ph.text. So I have two columns. The first column is volume of sodium hydroxide and the second column is pH. So this is a chemistry experiment. The aim of the experiment was to determine the concentration of unknown hydrochloric acid solution by titrating it with sodium hydroxide solution by monitoring changes in pH. So on the x-axis or on the first column, I have volume of the sodium hydroxide that I'm adding to the HCl solution, and on the second column, I have pH of the solution. So I saved all my data into a text file. So this file I called ph.text and I saved all the data into this file. This text file, you can make it in Windows using Notepad, for example. If you want to paste this into an Excel sheet, I just copy it and then I'll put it into an Excel sheet. So here each column is separated by a single space. So I click on space so that it reads the two columns and then paste the two columns into two distinct columns in the Excel. And then I press OK. So now I can see here all my data is pasted here. So here I have my data. Now I save this file as, so I save it as ph.csv. So I save it as a CSV file. So I select the format here as text CSV and then I save this file. CSV is comma separated values. So I have saved this. So I click on use text CSV format and then I click on OK. So now my file is saved in my home directory. So if I want to check the values ph.csv. So here I see that the two columns are separated by a comma. So CSV is comma separated values format. So this can be conveniently read by Python. So now I have all my data ready. So let us start Jupyter Notebook. So for starting Jupyter Notebook, you need to install Anaconda installation of Python. So you go to Anaconda website and then install Anaconda Python installer. After that, if you are using Windows, then you can go to Windows search feature and type Anaconda Navigator. So here I am typing in the terminal. In Windows, you need to type it in Windows search feature. So the third one is the Jupyter Notebook. So now I launch the Jupyter Notebook. So this brings me to my home directory. So in home directory, I have a notebook called ph.ipython notebook. So in this notebook, I have already written the code. So we will see it and then we'll check it step by step. When I click it, it opens in a new tab in my browser. So the first step in the program is loading all the required modules. So here in the first step, we have to import all the required modules such as Numpy, Pandas, Matplotlib. Numpy, the numerical Python, which is for vector and matrix operations. Pandas is for data analysis and matplotlib.pyplot. So this is for plotting or visualization of the data. So this I name it as PLT. So the name of the module is matplotlib.pyplot, but I save it with the name PLT. So that means if I call PLT, that means I am calling matplotlib.pyplot. And then I have some other modules that I need to get. For example, matplotlib.ticker. This I need for getting tick marks on the coordinate axis, on x-axis and y-axis. If I want to have some minor tick marks, so I need this. So I import it as ticker module. And then I also need some formatter functions. So from matplotlib.ticker, I import a function called format string formatter. So this is for having a desired number format. For example, if I want to get two decimal places in a number, I need this function called format string formatter. I load it with the name formatter. In the next step, I want to get some fonts. For this, from matplotlib.font_manager, I import a class called font properties. So I name it as font. So this first I will call this. So this is a class. So I call this class. So I name it as font. Then I use a method called set_name and use the Arial font. And finally, if I want to see the plots directly in my Jupyter notebook, so I have to have this command %matplotlib inline. So if I want to execute the code block, I put my cursor here and then press Shift Enter. So now it got executed. And then I go to the second block and then I execute this piece of code by pressing Shift Enter. So these lines, these are all comments. For example, here you have a comment. First, we have to import all the required modules. And here there is another comment. So these lines are not codes, but these are comments for the code. So now again, here is my code. So now I want to load my data. So my data is saved in a file called ph.text. In this file, each column is separated by a space. So that is denoted by /s. So separator is SCP is separator is space or one or more spaces. So plus implies that I can have more than one space in between the two columns. This data I am loading into a data frame. So in Python, we use an object called data frame, which is like an Excel. So this file name, this data frame, I name it as df_ph. So then I call my data frame by typing df_ph. So when I do this, then it will call my data frame and print the data frame on the screen. So let us say that you don't want to use text file, but if you want to use CSV file, then you type CSV here. And here you don't need to use this separator equal to /s because in CSV file separator is comma. So the first column, as you have already seen, is volume of sodium hydroxide in ml. The second column is pH. So towards the left hand side, you see a number that is the row index. The number starts with 0. So now I have loaded my data into a data frame and saved it with a name df_ph. In the next step, what I will do is I will generate an empty frame for making the plot. So to generate an empty frame for the plot, I use this command. So I call figure, axis is equal to plt.subplots. The first number indicates number of rows. So number of rows I can also call n rows. Number of rows is equal to 1. And then the second number is number of columns is equal to 1. And the third is figure size. The first number is width of the figure in inches. So 5 inches width. And the second number is height of the figure in inches. So 5 inches width and 5 inches height. One row, one column. So all this command we assign to two variables called figure, ax. So it is figure, axis. Fig refers to figure, ax refers to axis. So now I execute this. So here we have only one row and one column. So now I have generated the frame for making the plot. So next I define what is x and what is y. So you remember that I have loaded the data frame and named the data frame as df_ph. So here you see I named my data frame as df_ph. The first column name is volume_sodium hydroxide ml. The second column name is pH. So the x. So I assign df_ph volume of sodium hydroxide to the variable x and df_ph of pH. So this second column I assign the name y. So now I have defined my x values and y values. X value is the volume of sodium hydroxide column in my data frame, and y value is the pH. Y values are the pH values in my data frame. So now I am ready to plot. So for plotting, I use ax.plot. So AX is for axis. On axis, we plot X values, Y values, and I use the color red color, and I use the marker circle. So this is so for circle we use O, small o, for getting the circle marker. So after that, if I press FIG here, then it will make the plot. Let us say that I don't want red color, but instead I want black color. So I change the color to black, and then I see black colored circles. So now I have the figure. So, but the problem here is I don't have any labels on the x-axis, as well as the y-axis. So for this, so first I want to have, first I want to define the limits of the axis and title for the x-axis and y-axis. So for first I will define the limits. So for x-axis, setting the x-axis limit, I use the function set underscore x limit. So on x-axis, I want to start with 0 and end with 17. On the y-axis, I want to have the limits from 2 to 12. So for this, we use set underscore x limit for x limits and set underscore y limit function for y limits. So then I want to put labels on x-axis and y-axis. So for this, I use the function set underscore x label, and the name of the label is volume of sodium hydroxide added in ml. And for my y label, the name is pH. So for this, I use set underscore y label function. So now I can execute this, but it won't show the figure. If I want to see the figure and what are the changes done to it, I need to press FIG and then execute this box. Now you see that we have labels on x-axis and y-axis. On x-axis, we have volume of sodium hydroxide added in ml, and on y-axis, we have pH. And also, we see that x-axis starts from 0 and goes up to 17. On the y-axis, we have limits from 2 to 12. But here you see that there are no tick labels. And also, let us say that a volume of sodium hydroxide, I don't want it as 2, but I want it as 2.0, 4.0, 6.0, and so on. So now I will fix these two things. One, I'll have the decimals, one decimal place like 2.0, 4.0. The second thing is I want to have some tick marks in between 0 and 2 and in between 2 and 4. So for this, I use the following functions. For getting the decimal places, I call set underscore major formatter function on x-axis, and then the format I indicate as %.1f, that is 1 decimal place. Similarly, on y-axis, I don't want any decimal places, so I will give 0f. So now I want to have tick marks. So for this, I use the function set underscore minor locator on x-axis as well as on y-axis. So on x-axis, I want my tick marks to appear at 1.0. Let us say that on y-axis, I want my tick marks to appear at 0.5. So I put 0.5 here. Then I type FIG so that I can see my figure. So here you see that at every 1, you have a minor tick mark. So here in between 0 and 2, at 1, there is 1 tick mark. And in between 2 and 4, at 3, there is 1 tick mark. On the other hand, at y-axis, you have tick marks at 0.5. So 2, 2.5, 3, 3.5, 4. Instead, if I just want tick marks only at intervals of 1, then I put 1 here. And then I see that the tick marks appears only at 11, 9, 7, and so on. So now I want to save my figure. When we have multiple plots, there is possibility of overlapping. So to avoid this overlapping, I use this tight layout function. And then I'll save the figure by using this save fig function. fig.savefig, and I save it as ph.png. So I save it in PNG format with resolution 600 dpi. If I want to save it in a PDF format, I can have PDF here, and then I execute this. So now it got saved in my home directory. So I can go and check it. So yeah, this is the ph.pdf file. So this is the final plot that we have generated using Python. So having generated the plot, now we would like to find out the endpoint of our titration by using this plot. For this purpose, we would like to find out the volume at which there is a sharp change in the pH. For example, here if you see, from here to here, there is a sharp change in the pH, but we would like to locate the end point precisely. So it is approximately at around 8, but we want to know the exact end point. So a more elegant way to do this is find out derivative of pH with respect to volume and see where the derivative is maximum. So first what I will do is find out changes in pH and with respect to changes in volume and see where this derivative is maximum. For this purpose, I go back to my code and then I'll calculate the differences in pH and differences in volume by using a function in Numpy called differences. So dpH I define as differences in y, because earlier I defined y to be the pH values and x to be the volume of sodium hydroxide. So now I calculate the changes in pH and changes in volume. dpH is equal to np dot differences of y, and changes in volume I define as np dot differences of x. So now we have both changes in pH as well as changes in volume. So now I find the relative change by calculating changes in pH divided by changes in volume, and this round function I use it to round it to 2 decimal places, and I assign these values to the variable dpH underscore by underscore dv. So we can check these values by typing the name of the variable dpH underscore by underscore dv and then pressing shift enter. So these are the values. Just for sake of checking if these values are right, we go back to our original data and see the changes. So here you see 3.22 minus 3.16, which is 0.06, and the difference in volume is 1 minus 0. So 0.06 divided by 1. So the first value will be 0.06, as you can see from here. So now using these values, changes in pH, changes in volume, and changes in pH relative to changes in volume, I will make a new data frame to store these values. For creating a data frame, I use this command pd.dataframe, and I name this data frame as df underscore dph. Now I create a new column in this data frame and I name this column as volume underscore sodium hydroxide ml. And the values I take from my old data frame where I have this df underscore pH data frame, and the first column volume underscore NaOH ml. So this column or this series I take from my old data frame and I put this into my new data frame df underscore dph. So after this, I want to create a new column with values of changes in volume. So the new column df underscore dph of dv. So for this, I will have these dv values that I have generated here. And then I will create another new column with the name dph, and I save the values of the changes in pH I have obtained here. And finally, I'll generate another new column with the name dph underscore by underscore dv, and the relative changes in pH with respect to changes in volume that I have calculated above. These values I assign it to this column. So now let us see this new data frame that I have generated by typing df underscore dph and pressing shift enter. So this is my new data frame. So the first column is volume of sodium hydroxide in ml. So this one. And the second column is the changes in volume dv. And the third column changes in pH dph. And the fourth column relative changes in pH with respect to changes in the volume. So here as I scroll down, I see that the value is maximum here. So this is 4.40. So this corresponds to the volume of sodium hydroxide of 8.8 ml. So we can extract this data from this data frame in the next step. So now to find out the endpoint of the titration and volume corresponding to it, I would like to find out where the derivative is maximum. So if I find where the derivative is maximum, the volume corresponding to this maximum value of the derivative is my endpoint. So for finding out the place at which the derivative is maximum, so I go through this column df underscore dph of dph by dv. So this is the name of the column. So in this column, I want to look for maximum value. So when I use this function called dot max on this column, so when the value gets equal to the maximum value, and then I want to extract the row for this maximal value. So now if I type derivative underscore max variable name here and press enter, so this extracts the row, the 11th row, where we have the maximum derivative value of 4.4. So this extracts this 11th row. So now we see that the corresponding volume is 8.8 ml. So now I want to have only this number. So for this, to extract this volume, now I again write derivative underscore maximum of volume of sodium hydroxide. So this is like a sub data frame where I have only one row, and from this row I want to extract only one number, that is the volume of sodium hydroxide. And the endpoint I want to be in a float format. So I write it as endpoint is equal to float of endpoint. Then if I type endpoint here, so then it shows me the volume corresponding to the endpoint. So this is 8.8 ml. So in this way, we find out the endpoint, and using this endpoint, we can calculate the concentration of given HCl solution. In the experiment, I have taken 10 ml of HCl. So I call V1 is equal to 10 ml, and V2 is the volume of sodium hydroxide. So this is 8.8 ml that we have obtained. So I define V2 is the endpoint, and N2 is the normality of sodium hydroxide. This I have taken it as 0.1 normal. If we have different volumes and different normalities, we can change these values accordingly. And finally, N1 is the normality of HCl. We calculate it as N1 V1 is equal to N2 V2. Therefore, N1 is equal to N2 V2 by V1. So if we do this, then we get the concentration of HCl, and we round it off to 2 decimal places. So we get concentration of HCl as 0.09 normal. So the thing is, using numerical Python, Numpy, we can calculate the differences in our variables, changes in our variables, and then we can calculate the relative differences. And from these relative differences, we can check where the difference is maximal and the volume of sodium hydroxide corresponding to this. In the description to this video, I have provided a link to download this Jupyter notebook. Thank you.